have a vector A that has a strength of 5 newtons and is making an angle of 33 degrees above the x-axis. So we have a vector here that is given in terms of its magnitude and direction. What we want to do is compute its components in terms of an x component, which is asking how much points along the x direction, and a y component, so how much of the vector A points along the y direction. The reason we might want to do this is we might have to do something else with this vector to combine it with another vector. If we have all those vectors in their component representation, then we can just add them together component by component. If they're all in a magnitude direction form, then we can't do that, at least not as easily. You'd have to draw them all out and use graph paper, so you have a scale, and use a protractor to get the direction of the resultant. So in general, it's easier to work with the vectors when we break them down into their components, and that's what we're going to do here. So pictorially, what we're doing is we're saying that there's some vector A, and as long as I don't change its length or the direction that it points, then it's still the same vector. So it doesn't matter that I had it up there or now I have it here. And that vector is made out of two perpendicular components. There is a part of A that points along the x direction, and then perpendicular to that is a component or a part of A that points along the y direction. So to write out the vector A in terms of its components means finding what these lengths are. How long is A sub x and how long is A sub y? And we know that this angle is 33 degrees and it is a right triangle. By construction, x is perpendicular to y. Okay. Maybe a handy thing to remember as we sort of dive into doing this is that the adjacent side over the hypotenuse has to be cosine of 33 degrees, and the opposite side, A sub y over the hypotenuse, is equal to sine of 33 degrees. Just for completeness, opposite over adjacent would be tangent. So AY over AX would be tangent of 33 degrees. We're not going to use that in this particular problem, but I thought I'd throw it in there so you can see your old friend tangent. All right, so to find the x component, and that means I am taking the magnitude of this vector A sub x, that is going to be the length of the hypotenuse, which is A, no vector symbol, times cosine 33 degrees. So that's 5 newtons, and then keeping a few digits in cosine of 33, get that to be 0.8387. So that tells me that the x component, 4.193 trying to find the y component, which is asking what is the magnitude of this vector, vector a sub y. It's going to be the length of the hypotenuse times sine of 33 degrees. So that's 5 newtons. And then keeping that same 4 digits, sine of 33, 0.5446. And that tells me that the y component of the vector A is 2.723 newtons. So the vector A, we could have magnitude and direction form, it'd be 5 newtons at 33 degrees above the x-axis, or writing it out in terms of components, could write that as vector A, 4.193 newtons along the x-axis, plus 2.723 newtons along the y-axis.